in this class, let us see. Let us continue with that, right? So what I was telling, to avoid this chemoselectivity problem, what we do, we will disconnect first the reactive group, that is disconnect reactive group first. So what happens, how it happens, that thing we shall see now. So what, let me take one example here. So here I have this compound, and here O, CH2, CH2 and Br. So I have two possibility. Here also heteroatom is there and carbon. Here also heteroatom oxygen and carbon is there. But here I am going to clue, not this. The reason is, see here, this group is very reactive. So always we need to see that the reactive group should be cleaved. Why we do this is to avoid this chemoselectivity, right? So how I will cleave? I will cleave like this. So I can show this like E. Let me take this as F. So if I cleave like E, I will get this compound. So oxygen will be there, oxygen, CH2, CH2 and Br, and here I will get O minus. There is all possibility of reaction this O negative with this carbon, right? So we won't cleave like this. So one more reagent will be this one, CH2 plus. We can show synthon, or we can also show the equivalent reagent. How you will show the equivalent reagent? See here, just I will negative, I will put hydrogen here, and here instead of writing positive I can write here chlorine, right? So this is wrong. So we never prefer this one cleavage. We always prefer this cleavage, which this F, see here, which I am writing now here. So what happens here, I will get bromine, CH2 and bromine. This one, if I cleave here, I will get this one, plus one more thing is oxygen is there as usual. O minus, instead of writing O minus, I can write OH, O, CH2, PH, right? So here what happens, this is very reactive. It can first react like this, further there will be no problem. So this cleavage is very good, right? So to avoid chemoselectivity, we always disconnect the one which is more reactive. Further, this can be easily retrosynthesized. So here also we can do retrosynthesis. So what I can do, see here, this compound is there, I can break, next I will break like this. So what I will get, I will get this thing, OH here and here, OH and here, PH, CH2 and Cl, Cl or bromine, OTS you can put, one which is good living group, right? So like this. So always you should remember, I have told this also, the last retrosynthetically cleaved, this last, let me write, this is last retrosynthetically cleaved will be the first one to react. That thing I have told you while writing reaction. How you will write reaction, you please note it down. Let me write with different color here, right? So the last retrosynthetically cleaved or disconnected, you can write, will be the first one to react. That thing you remember. So here this is my retrosynthesis. First I got this, from further I broke down into this retrosynthetically. So while writing the reaction, I have told, once you have written retrosynthesis, then you need to write reaction. So the last one which is retrosynthetically cleaved will be written first. So I'll add this thing. In presence of small base, I can do the reaction, right? Or if you do in aqueous solution, no problem. Water is there, directly we will get this compound. See here, O and CH2 PH. This one we got it, right? This one we got it. Further, I am adding 1,2-dibromoethane. This is 1,2-dibromoethane. 1,2-dibromoethane. Ethane means 2 carbon. Ethane. Ane means all are saturated, that is alkane. So these are nothing but 1,2-dibromoethane, right? So if I add to this, see here, only one oxygen is left, this won't react. So what happened? SN2 reaction, simply, and I will get the target molecule. But here we call it as product. In common reaction we call it as product, whereas in retrosynthetic we call them as CH2 CH2 Br, right. So this is our target molecule. I hope you got it, right. So this is the reaction, right. Yeah, I hope you got it clearly, right. So this pH2 CH2Cl is there, right. pH CH2Cl, I can call it as BnCl also, right. These shortcuts you should know. BnCl, Bn, where Bn means this structure CH2 CH2, and this will be attached to something Bn, or I can draw like this also, pH CH2, it will be attached to something. So these are called as benzyl, BnZyl, benzyl. So this is nothing but benzyl chloride, BnCl. So Bn, the structure of Bn is like this, right. pH CH2 I can write, or benzene ring which is attached to CH2. So this is benzyl. And Bz, that thing also you should remember, that is nothing but benzoyl, BnZoyl. This is benzyl and this is benzoyl. Benzoyl structure will be like this, CO, and this will be attached to something else, right. So we will simply write as PHCO, or benzene ring with CO. This is nothing but benzoyl, and that which I have explained, this is nothing but benzyl, right. I hope you got it, right. So let us see few more reactions of this retrosynthesis, and the next one is functional group interconversion. Let me write the heading, functional group interconversion. We shortcut, we call it as FGI, functional group interconversion, right. So let us see what is this functional group interconversion, right. This is also very interesting, you can see that. So here let me write one reaction instead of taking directly, or let me do the retrosynthesis, then I can easily explain you, right. So CO, Cl is there, and here NH, yes. So functional group interconversion, what I am going to do, see, is this is chloride, acid chloride, right. This is acetyl chloride we call it as, but here benzene ring is there, no problem. Acyl chloride, let us call it, right. So functional group interconversion, what I will do, instead of chlorine I can put this acid, right. So how this happens, if I write the reaction, you will get to know, right. These things you have done in lab also, but still I am going to explain it. So further what happens, see here, this is retrosynthetic arrow. FGI means functional group interconversion I am doing in retrosynthesis. This stands for retrosynthesis, because retrosynthetic arrow, whatever I write on that, it is all depend upon retrosynthesis only. So here what I will do, I am going to break this bond, CN bond. So what happens, see here, I am going to get this reagent, COH acid I am going to get here NH2, right, and here one more reagent will be this one, and here plus I can write, instead of writing plus, can I directly write the reagent, that is Cl, chlorine, right. So if I do the reaction with these two, I will get the product, right. So functional group interconversion, right. So let us write the reaction. So I have told, writing reaction, what we should do, the one which is retrosynthetically cleaved lastly will be written first. So lastly we got these two, so I will write these two first here, right. So COH, here NH2 is there, and here this heteroatom, heterocyclic aromatic compound. So what happens here, chlorine is there, it will give the electron density, and this nitrogen and chlorine will leave the system. So what happens, let us see that. So COOH, let me write here NH and NH, let me write here, and here instead of writing H here I can write like this, right? Further what happens, I'll add SOCl2, thionyl chloride, the structure we should know. SOCl2, 1 2 3 4, one lone pair will be there, right? So what it will do, it will make this OH as it will take this OH and it will put us chlorine. So what I will get, COCl and here NH and this is our starting material, right? So this is our target molecule, or we can call it here, we call it as product, right? So we synthesize this product, right? No, I think this is not the product. Yeah, this is one. Yeah, right. I hope you got it, how this happened. First, we always try to see this retrosynthesis and we got this product, and we always writing this reaction, we always start with this final retrosynthetic product. So this is the first. Further I will get this reagent, to that I add SOCl2. Here I have written functional group interconversion, right? But how that interconversion happened, it happened because of this SOCl2. For different interconversion we use different reagent to get the product, right? As we move further you will get to know what are the different reagent we use, those things you will get to know, right? So let us see amine. So let us discuss about this amine. Amine synthesis using functional group interconversion. Here it is very interesting, you will love it, right? See here what happens, R CH2 NH CH2 R, right? So here we know that nitrogen is a heteroatom and carbon is there, so you can clue and you will tell us that R NH2 you can write, sir, and here R is there, CH2 halogen any X, let us do, and if we do the reaction we will get this product, you will tell, no doubt it's true. But the problem is that this nitrogen is very active and also we won't get this. For example, let us write the reaction. So while writing reaction, what you will tell, RCH2NH2 let us take, and to that I am going to add this, sir, right? So what happened next, see here nitrogen will be there, it will give and we will get this product, and you will tell this is the starting material you got. But the problem is we can't add only this, right? Only one molecule. If we take 1 mole, it has got 6.023 into 10 to power 23 particles, right? So there are many like this compound RCH2X, right? So this nitrogen will be more active as it has got lone pair, so it will again react, so and we finally end up getting quaternary ammonium salt. See this one we will get. So this is nothing but quaternary ammonium salt we will get, right? We didn't get this target molecule. Which one is the target molecule? This one. This target molecule we didn't get it, but we got this quaternary ammonium salt, right? To avoid this, we do some functional interconversion, functional group interconversion. That thing we will discuss. Let me take one more example to explain this, when it happens, when not happens, then I will tell that functional group interconversion, right? So here NH2 is there as usual and COOET is there. So here this is just a reaction, not retrosynthesis. When I am writing reaction, I will show only this arrow, single arrow. Retrosynthesis means double arrow, like this I will show. This is retrosynthetic arrow. Simple like this arrow is nothing but I am going to write reaction. Whenever I show this arrow, it is understood that I am talking about retrosynthesis. Whenever I show this simple arrow, it is understood that I am talking about simple reaction, right? So here what I am doing, I am simply talking about reaction. So to this I am going to add XCH2R. So here, as I told quaternary ammonium salt in last example, you may tell, sir, here also you will get end up in getting quaternary ammonium salt. I will tell no, we won't, the further reaction it won't do, further reaction it won't do, So this is the final product I will get. I not even I will get this tertiary nitrogen CH2R. This also I am not going to get. You may ask why, sir, right? So this compound also I am not going to get. You may ask why, right? So the reason behind it is, see here, this nitrogen is attached to a bulkier group. This group is very bulky, right? Because of this bulky group, so what happened? Bulky group, so let me write bulky group, it won't do reaction, further reaction. So this reaction it never do, right? That thing also you should understand. So whenever bulky group is there, there is no successive alkylation, N alkylation. But here steric hindrance is not there. See here, this example, you can see this example. Here this nitrogen is not sterically hindered. No steric hindrance. Let me write no steric hindrance. So further reaction it will do, and it has given me a quaternary ammonium salt, right? But here because of this steric hindrance, see here nitrogen is there to which steric hindrance is there. So because of this bulky group, there is no further reaction, only we will get this product. So always you should remember these things. If this kind of compound is there, you always need to see whether it will do multi alkylation, that is N alkylation or not. If it is not doing, then it is fine. If it is doing, what to do? That thing we do is nothing but functional group interconversion of these amines. What we will do, that thing we shall see now. So to reduce the reactivity, what I will do, see, this is R, CH2NH, CH2R. So I will do functional group interconversion. Functional group interconversion. And here I am talking about retrosynthesis, not simple reaction, because I have shown this retrosynthetic arrow, right? So what I will do, here amine is there, I will convert this amine into amide. See here, CH, NH, CO, R. So this is nothing but amide. How I converted? I did functional group interconversion. So this reaction, when I write the reaction, you will get to know how this functional group interconversion happened, right? But for time being, just for moment you understand, I converted amine to amide and I call it as functional group interconversion, right? So further what I will do, I will break this CN bond, heteroatom and carbon bond easily broken, and I will break, right? So I'll show this retrosynthetic arrow and I will write CN, means CN bond is I am going to break. So I will directly write the reagent NH2. I have told we can directly write reagent, or we can also write this syntones, right? Those are nothing but intermediate. We can write those things also, right? Syntones, right? This is chlorine, right? I hope you got it, right? If I write the reaction, then you will get to know how I did this functional group interconversion. So let us see this reaction. So what happened? So RCH2 NH2 I took, to this I added, see here, Cl is there, CO, R, this thing I added. So nitrogen is having lone pair, it attacked this carbon, this electron density again come back, and chlorine is a good leaving group. Cl minus and this nitrogen NH, H plus it will take. So minus HCl has happened, and I will get this product R CH2 N NH CO R, right? But my target molecule is amine. So what I need to do, I have to do functional group interconversion. To do this in simple reaction, what I am going to add? I am going to add LiAlH4, reducing agent, or I can also add this BH3 in tetrahydrofuran THF solvent. If I use, I can reduce this and I can easily convert it to RCH2NH CH2R. So here it was amide and here I got amine. I hope it is clear, right? So reducing agent, about this thing also I have done videos, oxidation reduction. There in reduction I have talked about LiAlH4. You may ask me why not you have added NaBH4, and I will tell NaBH4 is not that react with this amide. Only LiLH4 is reactive. About those things in detail, I have done videos in that oxidation and reduction, right? So this is how we convert functional group interconversion of amines to amide, right? So let us see few more examples, right? So I hope it is getting clear to you. So in this, let us see second example in amines, right? So this is NH and here CH2R is there, right? To this, first what I will do, functional group interconversion. Whenever amine comes, we should do functional group interconversion first. The reason I have explained, because sometimes it may do N alkylation, multiple N alkylation to get quaternary ammonium. Sometimes it may not do. So we will be in confusion. So to get rid of it, I have told first you should do functional group interconversion. If you do that, what happens, the reactivity will be decreased. So here see, I am going to convert it into amide. So here amine is there and I got this amide by doing functional group interconversion. You may ask me, sir, why only we should do into amide only? There is not any other form. Yeah, it is there. That thing I will explain with time. With this video, I'll explain. No need to worry, right? So what happened? So amine I have converted to amide by telling functional group interconversion. How it happened, everything that while writing reaction, we'll get to know. So here retrosynthesis I am telling, right? So NH, so here this thing, and here CORCl. So this is the product. So if I want to write reaction, so the one which is cleaved lastly retrosynthetically, that I have to take first. So here as usual NH is there and here COCl. So nitrogen is having lone pair, it can attack here, electron density comes and chlorine leaves the system as HCl. That thing all you know, right? So here COR. So this is amide, but our target molecule is amine. So what I am going to add? I am going to add a reducing reagent. So what I can add? LiAlH4 I can add, or I can also add hydrogen catalyzed reaction. This also with some temperature, those keeping in mind, I can use this reagent also, hydrogen catalyst. I can make use with some metal and I can reduce this amide to amine. See here, right? So this is nothing but amine. CO is converted to CH2. Here 2 hydrogen comes. We never show that, but for understanding you can show it, right? I hope it is clear how this reaction happened. So I told not only we can convert amine to amide, there are few more types to convert, right? So let me give that third example. So R, sorry, let me write this one. R CH2 NH CH2R. So initially while I was explaining retrosynthesis, this is my retrosynthesis arrow, I told I will convert this to amide, this amide COR. But here I am not going to convert. One more, let me convert this amine. This is amine, right? I have converted to amide in my above example. Here I have explained about them, right? So here see, here I have converted amine to sorry, this is amine I have written. This is amide. This is not amine. Yes, yeah. So here instead of converting to amide, I will convert it into some other form. See here. This is also I call it as functional group interconversion. Here also I will call it as functional group interconversion. So what I will do, R NH, instead of writing like this, what I will do, just I will remove this H and here double bond and here R2. This, how I got this, when I write the reaction you will get to know. No need to worry, right? So I converted functional group. Further what I will do, I will break this bond. Heteroatom nitrogen and carbon bond I will break and I will get this reagent. So retrosynthesis R NH2 plus O R2. So here I can show hydrogen also. If I not show this hydrogen, then also no need to worry. That is understood. That is, it is aldehyde. I can show hydrogen, I may not show, right? So how this happened? If I write the reaction, you will get to know how this functional group conversion. I got this thing, you will get to know. So what happened? I hope this you got it. How if after breaking this, I get this amine and I will get this aldehyde. So the one which is lastly cleaved will be the one to react. So RCH2NH2, I will take this aldehyde. R2 hydrogen I haven't shown, it is understood, it is there. So what happened? It will react. So what I will get? RCH2 N, one hydrogen is there, Se, oxygen OH, it has happened, and R2. Further what happens? This bond will come here, it will move as OH minus, and this H plus, water will be eliminated at higher temperature, right? So what happened? R CH2 N double bond R. This one I got, right? So to get this starting material, that is amine, target molecule, so what I can do? I can add some catalyst which can reduce. I have told this is not alkene, but it is activated. Here I can use NaBH4 also to reduce this, or I can use LiAlH4, right? If I reduce this, I will get a amine, CH2N CH2R. So there is not only one case, but here I have explained only two cases: conversion of amine to amide, and one more is amine to this enamine, right? Enamine we call it as, right? Amines, no, carbon with double bonds is called imines, right? Imines, right? Here I have converted this amine to imines, right? I hope the name is correct. If it is wrong, please write it in comments, right? Let me correct it, or other people will also understand. I hope it is imine, because with time we also forget the name, right? So no need to worry. So here if I reduce it, right, everything I have explained, if I reduce this using NaBH4 or LiLH4, I will get this starting material. And also not only these reagent we can use this hydrogen in presence of catalyst, we can use, or NaCN is there, NaCN BH3, right? These are the substances are there, many reducing agent, about that also I have discussed, you can watch them, right? So fourth example, let us see one more, how to convert this. This is also very interesting, we will find it very interesting. I hope you are getting what I am explaining here. So this is the new kind of experience for you, because you have seen me explaining on board, but this is one more. For me it becomes very easy to explain like this. So I have come up with this. Let us see how effective it will be, right? So here I am doing retrosynthesis. Always you should remember, I should not tell, but it becomes mandatory for me to tell again and again. If I show this arrow, you should understand that I am talking about retrosynthesis. Yeah, why it is not working, man? God knows, right? Retrosynthesis, right? If I show this arrow, it is understood that I am talking about reaction. So here I am doing retrosynthesis. So what I am doing, I am breaking this bond, right? So what happened? So I will get this product, N is there, CH2 PH, and here N is there, and instead of writing that intermediates, I will write directly this compound reagent only I am going to write, right? And here I will get CO, CH2, OMe, and Cl. I hope it is understood. Further, see here, this retrosynthesis can I do? I won't convert to amide, I will convert to imines. So imines means how? I will remove this hydrogen and this hydrogen, and I can make double bond here, and I will call it as functional group interconversion. because in retrosynthesis we call it as functional group interconversion, right? CH2 CH2 pH, and here double bond I will get, here nitrogen, and here as usual other things remains same, and here fluorine. Further I can disconnect like this, so this is also retrosynthesis. So CN bond I am going to break and I call it as retrosynthesis. So what happened? See here, nitrogen is there, and here ketone I got, and here I am left with benzene ring having R group, and here NH2, right? These are the reagent I got, right? So if I write the reaction, you will get to know. So this is about retrosynthesis. All I have done is retrosynthesis. I hope you are writing with me, right? Otherwise you can pause the video and you can write. So let us see reaction. So reaction means this arrow I am going to use. See here. So the one which is retrosynthetically cleaved, that is the last one which is retrosynthetically cleaved, will be the first one I am going to take, right? So this is nothing but ketone, some kind of ketone, and here I have cleaved like this last, right? So I am going to do the reaction. So what happened here, it will, the reaction will be like this. Further what will be eliminated, everything, that reaction you have, you know all those things, right? CH2 CH2 pH, and here I will get double bond N, and here benzene ring to which fluorine is attached, right? So this is reaction. So I'll add some reducing agent like hydrogen catalyzed with metal. I'll make use of it, and I can get this thing also. So here CH2 CH2 pH, and here NH. Here also H is there, that is understood, you know. Now everything I need not to show. Here this is fluorine, not R group, right? Yeah, this is fluorine, not R group, right? So I got this thing. Further what I should get, my target molecule is this one, right? So target molecule is this. So I got this reagent. So I am going to add this reagent. So I am going to add CO, Cl, CH2OMe. Whether it is the same? Yeah, Cl, CO, CH2OMe. Cl, CO, CH2OMe. If I add this, N alkylation like this compound happens, and this reaction goes, and chlorine will be a good leaving group. It leaves the system. So what happened? See here. Nitrogen is there, CH2 CH2 pH, and here nitrogen, CO, CH2 OMe, and other things remains the same, F, right? So this is the product, we got it, right? So this is how the retrosynthesis and reaction goes in hand to hand, right? I hope you are understanding it, right? So everything is clear. The fourth example. Let us see two more examples. Let us see two more examples, then we shall end this video, right? So this is also very easy and important one. So what happens is that, see, let me take CF3. Fluorine is a very electronegative atom, so it acts as electron withdrawing group, right? So here nitrogen is there, hydrogen, CH2 CH3. So here functional group interconversion. So here amine it is amine. Now I will convert it into amide. I can convert it into amide, I can convert it to imines, right? It is left to you, which one you feel easy, whether it will be easy like this. Based on that we will cleave. Further what happens, see here, it is understood that I am doing retrosynthesis here, right? Why? It is based on this arrow. So this represents this retrosynthetic arrow. I may not tell every time, but it is understood, right? So what happened? So here cleavage happens. So cleavage we call it as disconnection in retrosynthesis, right? So here CH2 to NH2. right, and here I'll get this one, COCH2 Cl, right. So what we call intermediates are called as what? Synthone, right. We write synthone sometimes, or we write reagent, it's our wish, right. If in exam they asked synthone, then only will show that positive negative, then the equivalent reagent will show. But here no, I have directly written the final one, right. So these are the reagent, right. Further, so this is how we got it, right. Further, can I do retrosynthesis to this? Yeah, I can do it. See here. So here what I will do, I will remove this one hydrogen, and here one more hydrogen I will remove, right. Here it will get like this compound. See here, and these things, it is understood. Initially I started with amine to amide, now I am going to convert it into imines. See here, now I have converted it to imines, right. Further I can do retrosynthesis. I have written however I wanted, but in notebook you write it neatly, right. Neatly you can go, right. So CF3, not CH3, it is CF3, right. And here what happens, further I have cleaved here, and I will get ketone here, right. And ammonia, I can use ammonia, or instead of ammonia hydroxylamine, that also I can use. These are all equivalent, means how I want I can use. So this is the starting material I got, right. So if I write the reaction, see, I hope you have got. So retrosynthesis we have done. For initially what I did, amine, from that functional group interconversion I converted it to imines, right. Further from imines I got this one, this I further broke down into retrosynthetically into these things, right. So let us see how the reaction happens, right. So let us see the reaction. So what happened, a reaction, initially I will take the final retrosynthetic product first, CF3 CH2 COCl. So this is nothing but ketone. To this I am going to add hydroxylamine, I can add, or like this compound also I can add NH4OH, right. So what I will get, CF3, I will get nitrogen with double bond, and OH group will be there here, OH, right. This I'll get if I add this reagent. So further what I'll do, this is reaction, simple reaction. So hydrogen catalyst I will use to reduce this double bond, right. To convert into single bond I use this catalyst. So CF3 and CH2 CNH, and OH will also be left, and you will get NH here if I use this catalyst here, right. So you got this amine now, right. So this is nothing but amine. To this I am going to add this ACCl, acetyl chloride, CH3COCl. This we can acetyl, this is acetyl group, right. So we shortcutly call it as ACCl, which I have written here, right. So what happened, N acetylation takes place, CF3 is there, and here CH2 NH acetyl CO CH3, N acetylation we call it as. So it is nothing but N acetylation, right. Further what happens, N acetylation, whether it is the final product, no. So what I will do, I will reduce it, LiAlH4, amides will be reduced to amine. So this is nothing but amide, right. Amide means NHCO, this group is called as amide group. So it will be reduced to amine now. I hope you are understanding it. NHCH2 CH3. So this is our target molecule, here we call it as product, right. So first we will do retrosynthesis, then we will do reaction. If both will get correctly, and if other things are satisfied about reagent intermediate, then it is correct, right. So let us see last example. So pH is there, CH2 pH, CH2, see here, NH is there, and here like this compound, right? Tertiary butyl we call it as, right? So first functional group interconversion. So what I will do, I will remove this hydrogen and this hydrogen, this hydrogen and this hydrogen. So what I will get, pH, CH2, double bond N here, and to this tertiary butyl group, right? This thing you understood. Further what I will do, retrosynthesis, this arrow represent retrosynthesis. So retrosynthesis I will do. Further I can break it like this. Ketone I can easily convert, pH, CH2, ketone I have converted, and one more reagent will be this one, NH2, right? So this is the thing. So if I want to write the reaction, the last which one I got, with that only I will write the reaction. So reaction means single arrow I am going to use. See here, pH, CH2, CO, CH3. To this I am going to add H2N, right? So what happens, this reaction I will get double bond here, N here, to this like this, and here, right? Further hydrogen catalyst I will use to reduce that double bond, and I will get single bond, pH, CH2, NH, tertiary butyl, and this is the starting product, right? In next class let us see few more things.